Now in this video we will learn about the positive monotonic transformation of utility function and marginal rate of substitution. In the earlier video I have explained the monotonic transformation of utility functions. Okay, so what is meant by monotonic transformation? It is simply monotonic transformation is a way of transforming a set of numbers into another set that preserves the order of original set. I have explained it in earlier video, so let's give one example to make this stuff uh, relevant for this MRS thing. Okay, so if we have a utility function u of xy is equal to xy, okay, x into y, let me write it here, xy, and we have another utility function u x y is equal to 10 times x y. Okay, we say these two utility functions will be positive monotonic transformation of one another if the preference ordering of the bundles does not change. Okay, so let us say we have the consumer is consuming here bundle A. Okay, bundle A is, let us say, 1 and 1. If consumer is consuming bundle A here, utility he is getting from this bundle A will be equal to, so we have 1 into 1 here, so this is 1. And let us say consumer is consuming another bundle which is 3 and 2. In this case the utility that the consumer will get will be equal to, so we have x into y, so 3 into 2 is 6. Here we can see consumer is preferring bundle A over, sorry, bundle B over A. Okay, let's take this very example here. Let us say we have same bundles, that is 1 1 here, and what will be the utility in this case? So we have u is equal to 10 into 1 into 1, which equals to 10. And from bundle B we have this bundle here. Let's take this again, 3 2, and the utility that the consumer will get will be equal to 10 into 3 into 2, which comes out to be 60. Here we can see consumer is preferring bundle B over bundle A because 60 is greater than 10. That means consumer is preferring bundle B over bundle A. So we say these two utility functions are positive monotonic transformation of one another because the ordering of preferences does not change. In the original bundle, in the original utility function, consumer is preferring B over A, and in this new utility function consumer is sticking to the same preferences, that is he is preferring B over A again. Okay, so I have explained this very stuff in earlier video, you can check that very video. Let's talk about the what we call monotonic transformation and marginal rate of substitution. Okay, so the basic thing is that marginal rate of substitution does not change when a transformation of utility function is undertaken by a positive monotonic transformation. Okay, so there is no change in the MRS. So let's make this stuff relevant here. So let us say we have a utility function u x y is equal to x to the power 0.4 y to the power 0.6. Okay, uh, now what will be the MRS of this utility function? Marginal rate of substitution is simply the marginal utility of x upon marginal utility of y. Okay, so marginal utility of this very function taking derivative with respect to x here, so we have 0.4 x to the power 0.4 minus 1 comes out to be minus 0.6, and we have y to the power 0.6. Okay, I will not go into details, I have explained this stuff earlier also in number of videos. How do we take the partial derivative with respect to x here? So similarly taking with respect to y, so this 0.6 will become coefficient. We have x to the power 0.4 y to the power, so 0.6 minus 1 comes out to be minus 0.4. Okay, if we rearrange this very stuff, transposing this term to numerator and this term to denominator, we will get 0.4 y to the power 0.6 plus 0.4 and here we will get 0.6 x to the power 0.4 plus 0.6. Okay, simple transformation I have made here. So this comes out to be 0.4 upon 0.6, which so 0.6.4 comes out to be 1, so we get y upon x. This is our marginal rate of substitution. Okay, marginal rate of substitution. Now let us say we have what we call the monotonic transformation of this utility function is, let's denote it by v x y is equal to 2 log x plus 3 log y. Okay, I am saying that this utility function is positive monotonic transformation of this utility function. Okay, then if this is true, then the marginal rate of substitution should be same between these two utility functions. Okay, now let's find out the marginal rate of substitution here. Marginal rate of substitution is simply marginal utility of x upon marginal utility of y. So marginal utility of x means taking partial derivative with respect to x. So we have 2 derivative of log of x is 1 upon x. Okay, since no x is involved, its derivative will be 0. Similarly, marginal utility of y means taking partial derivative with respect to y this time. So since no y is involved in the first term, so here and we have 3, and the log of y, its derivative is 1 upon y. Okay, so this will become 2 upon 3, or it's like this, 2 upon x whole divided by 3 upon y, which can be written as 2 upon x into y upon 3, which comes out to be 2 upon 3 into y upon x. Okay, this is our marginal rate of substitution of this very utility function. Here we have also 0.4 upon 0.6. This will come out to be, let me write it here to make the things easier for you. So this is 4 ones are 2 twos are 2 threes are, so we will get 2 upon 3 y upon x. Okay, so the point that I want to make here is that marginal rate of substitution does not change when a transformation of a utility function is undertaken by any positive monotonic transformation. That means if we have this utility function, and if this utility function is the positive monotonic transformation of this utility function, then the marginal rate of substitution will be same between these two utility functions. Okay, so I hope I make myself clear in this video. Thank you.